everyone. I am Dr. Kiranmayi, Area Chair and Assistant Professor, Digital Transformation and Operations, School of Business, Aditya University. In this present lecture, I am going to discuss about the special cases of Simplex method. So, like degeneracy, multiple alternative solutions, when we can understand whether there is unbounded or infeasible solution. All these are considered as special cases in Simplex method. And coming to the first special case, that is degeneracy. So, what is degeneracy? When the solution is said to be degenerate. So, a solution is said to be degenerate, or in Simplex problem, degeneracy has got existed when there exists for the minimum ratio is used to identify the key row. So, if there exists tie in the minimum ratio in this way, then it is considered as the solution is going to be degenerate. Such kind of situation is considered as degeneracy. Okay, and not only that, a solution is said to be degenerate solution if at least basic variable value becomes 0. So, what is a basic variable? Basic variable is that variable which represents the identity matrix in the Simplex table. Okay, so here S1, S2 are identity matrix in the Simplex table. So, these two are called basic variables. The solution is said to be degenerate if the value of these basic variables is 0. That is, so see here, the solution is optimum, but the value of the basic variable S2 is 0. But the solution is, it is the optimum solution because all the Z values, all the net evaluations are positive. So, all the net evaluations are positive, it indicates that the optimum solution is reached. But, however, still there is existence of this basic variable with 0. So, this kind of situation denotes degeneracy. So, this is how we can understand degeneracy in Simplex table. So, based upon two concepts, we can understand whether the solution is degenerate or not. One is, if there exists tie between the variables in the minimum ratio, the solution is going to be degenerate, and also in the final optimum solution, if still there exists basic variable with the 0 value, that also denotes the case of degeneracy. Another special case which is called multiple alternative solutions. What do you mean by multiple alternative solutions? A Simplex problem or an LPP may not have single solution, and a linear programming problem may have multiple alternative solutions, and such kind of linear programming problem is said to be have multiple alternative solution. So, how can we understand that a linear programming problem which is being solved by Simplex method has multiple alternative solution? If at least one or more non-basic variables. So, what are the non-basic variables? The variables which represents the matrix which is not identity matrix. Okay, and which are not set to 0. Such variables are said to be non-basic variables. These non-basic variables is going to be 0. Then in the optimum table, that is, if all the net evaluations are positive, we understand that the solution is optimum solution. In that optimum solution stage, if one or more non-basic variables, their value as 0, then such a situation denotes that the LPP is having multiple alternative solutions. See here in this problem, here all the Z net evaluations are positive. It means that the solution is optimum solution. Even the solution is optimum solution. See, the value of non-basic variables, here x1, x2 are said to be non-basic variables because they are not denoting the identity matrix. So, the value in the final optimum solution, so here all the net evaluations are positive, therefore, it is a situation of optimum solution. So, all the net evaluations are positive, but still here the values net evaluation for x1, x2 are zeros. So, then we can understand that the problem is going to have multiple alternative solutions. See, if we proceed for the next iteration, this is also a kind of optimum solution. Since all the net evaluations are positive, still we have zeros for the non-basic variables in the net evaluations row. So this indicates that linear programming problem has multiple alternative solution. If we proceed for the next iteration, we will get another solution. See here at this stage, the solution is Z is 10, S1 is 5 by 2, S2 is 5 by 2. That is one solution, and which is optimum solution. And if we proceed to the next iteration, and the solution is going to be differ. Okay, so it means that the problem is going to have multiple solutions. See here also Z value 2, X2 is 5, S2 is 3, a different solution. Likewise, if we proceed for the next iteration, we are going to get another solution. That is, the linear programming problem may have multiple alternative solution. Like this, if the value of non-basic variable in the net evaluation row has 0, it indicates that the linear programming problem has no unique solution. It has multiple alternative solutions. So, which is another special case of linear programming problem in simplex method. And another special case is unbounded solution. When the solution is said to be unbounded solution. The solution is said to be unbounded solution if the objective function can be extended to the farthest point, to the infinite point, that the solution exists somewhere else at infinite place. Infinitely the solution exists. So, then the solution is said to be unbounded. There is no boundary. Solution space extends to the infinite space. Okay. Such kind of solution is said to be unbounded solution. So, in simplex method, how can we know that the solution is unbounded solution? In the simplex method, in the key column, if there exists negative values, if the key column consists of negative values or zeros, if the elements in the key column are negative values, all are negative, or all zeros, combination of negative and 0, which makes to not to find the minimum ratio. If the key column consists of negative values or zeros, we could not find the minimum ratio. So, without finding minimum ratio, we cannot identify key row and we cannot proceed to the next iteration. Therefore, this is an indication of unbounded solution. That is, the key column consisting of negative values or zeros or combination of negatives and zeros. So, that is how we can identify the solution is bounded or unbounded in simplex method. And the last special case is infeasible solution. When the solution is said to be infeasible solution. Infeasible solution means the linear programming problem does not have solution, optimum solution. So, the linear programming problem sometimes may not have optimum solution satisfying all the constraints simultaneously. Okay. So, if there is no solution satisfying all the constraints, then the problem is said to be having infeasible solution. Okay. That is no solution to the linear programming problem. This kind of infeasible solution we may find or may occur when the constraints are of greater than type or equal to type. If in the simplex problem or if in the linear programming problem, if all constraints are less than type, then we do not find this special case, that is infeasible solution. If all the constraints in the linear programming problem are of less than type, we do not have the case of this infeasible solution. But if the linear programming problem has either greater than type, equal to type, since for greater than and equal to type of inequalities only, we introduce artificial variables. For less than type, we introduce only slack variables. For equal to and greater than type of equations only, we introduce artificial variables. Why? Because infeasible solution can be identified in simplex method if at least one artificial variable has positive value in the optimum solution stage. When all the net evaluations are positive, we understand that the solution is optimum solution, right? So, at that stage, still there is presence of artificial variable with positive value, then the solution is said to be infeasible solution, right? Let me explain with the help of an example. See here, in this case, all the net evaluations are positive, indicating optimum solution. So what is the solution at this stage? The solution at this stage is Z is minus 396 and S1 is 2, R1 is 3. See, still here we have artificial variable R1 with positive value. So this indicates that the solution is invisible solution. So at the optimum solution stage, still there is presence of artificial variable with positive value. In this way, this kind of situation denotes that the solution is infeasible solution. In turn, we can say that the linear programming problem has no solution. By the end of this lecture, we understood various special cases in simplex method, which is used to solve the linear programming problem. So, special cases are like nothing but degeneracy, multiple alternative solutions, unbounded solution, infeasible solution. So, the linear programming problem may have all such kind of solutions which are considered as special cases in simplex method. Thank you.